Okay, the last example was about two lines that intersect. Lines don't have to intersect. One way that you're familiar with about lines not intersecting is when they're parallel. That can happen in two dimensions. We're going to have two lines side by side. Okay. The example we're coming to after this one is about lines that don't intersect and aren't parallel. That can happen if the lines are skew. So you can have a line like that in three dimensions and another line that misses it by being above it. So even on the screen, you can see these two pens are not going to ever intersect because there's room in three dimensions for them to miss each other. So in this case, we need to show the lines are parallel. That's a very easy case. Okay. How do I find out whether lines are parallel? Well, this is just to do with effectively the angle between the lines or the directions of the lines. So as with the angle between lines, all I need to do is look at these directions. So my directions, I need one column vector for each line. So the directions of the lines are 2, 1, 3 for the first line, and the second one is -4, A, B. And I'm told that these lines are parallel. And I've got to say what A and B have got to be. Well, remember, for vectors to be parallel, one has to be a multiple of the other. Okay. Now, the x values show me what multiple that has to be. In order to get turn 2 into -4, I need to be taking my vector 2, 1, 3, and I need, if I'm going to get a -4 here, I need to multiply it by 2. So therefore, in order for, sorry, -2 times 2 is -4. So therefore, the other two parts of the vector are just forced. If it's going to be parallel, this has to be -2 times 1, which is -2. -2 times 3 is -6. So therefore, that has to be my direction vector and for parallelness to happen. And therefore, A has to be -2 and B has to be -6. So that example shows you that the case of parallel lines is very straightforward. One of the direction vectors has to be a multiple of the other.